Welcome back to the channel. Today we are diving into an essential concept in programming and system design, concurrency. It's something that powers everything from your browsers to video games, ensuring smooth and efficient multitasking. But what is concurrency and how does it really work? Let's break this down. So, let's first understand what is exactly concurrency. At its core, concurrency means an application can is making a progress on more than one task at the same time. But here's the key. It doesn't mean those tasks are running simultaneously. And instead, the CPU rapidly switches between tasks, creating the illusion that everything is happening at once. Okay, this is not easy to understand. Let's make an example. For example, when you are writing code while listening to music, your CPU alternates between processing the music and responding to your keystrokes so quickly that it feels like both are happening simultaneously in the same time. So this is the feeling of concurrency. So it's basically your your CPU your CPU core. For example, your CPU core have like task 1 and task 2, and it does these tasks like task 1 and task 2, and this task. Oh, okay, no, let's make it quite clear. Okay, I will make it with well because it's quite important topic to talk about. So let's say that we have our CPU core. Let's make it wider. And let's assume our CPU is doing two tasks. Okay, so we have this task, task 1, and task 2. And basically, in concurrency, we said that concurrency means that an application is making progress on more than one task at the same time. But the key is it doesn't mean those tasks are running simultaneously. Instead, the CPU rapidly switches between tasks. So we have, for example, like task 1. Okay, I'm pretty bad at typing things. Let's make this one again. We have task 1 and task 2. And let's just create. So we have this task 1. And task 1 currently, can I make it like... And task 1 right now is going like that. And it's continue like that. And on task 2, basically we said that it switches between two tasks. So in task 2, okay. So this is how it works basically. So first your CPU will do the first task, and it will continue doing it, but it will jump to do the second one and go back to the first one and go back to the second one. And it's so quick, you feels like that your CPU is doing the two tasks in the same time. For example, we said before, imagine that you are writing code and while listening to music, your CPU alternates between processing the music and responding to your keystrokes so quickly that it feels like both are happening simultaneously. So let's clear up a common misconception. Concurrency is not parallelism, and we will make a video about parallelism, and after that we'll make another video about what are the differences between them. But while concurrency involves switching between tasks to make progress on multiple fronts, parallelism actually requires multiple CPUs or cores executing tasks simultaneously. In concurrency, the goal is to keep the CPU as busy as possible by switching tasks when it is idle, like waiting for database query or file read operation to complete. So let's try to understand how it works. We took an example. But if we want to really understand how it works, there are three steps we need to understand, or 3 points we need to understand. First, we have something we call context saving. When the CPU switches from one task to another task, it saves the current task's state. Things like the program counter and CPU registers into memory. The second thing, we have context loading. Let's make this quite wider. And make them with numbers. No, all of them. The context loading, like the CPU then loads the state of the next task and starts executing it. And finally, we have what we call a rapid switching. And the rapid switching, as you can see here, basically the process repeats so quickly that to the user it seems like all tasks are running simultaneously. But here is the catch: context switching isn't free. It introduces overhead, consuming time and resources. Too much context switching can actually degrade performance. Like, but why is that? Why the CPU is doing that, and why concurrency is important? The primary objective of concurrency is to maximize the CPU utilization by minimizing the ideal time. Let's say one task is waiting for a database transaction, and instead of letting the CPU sit idle, it can switch to another task and keep things moving. So this is how it works, and this is why we use concurrency, and this is why it's a pretty important. But let's just try to take some examples. Let's say that we have like a web browser. Let's try to understand. Okay, I'm pretty bad at writing, but let me try to do it again. Web browsers. Okay, so modern web browsers uses concurrency to render web pages, fetch external resources like images and scripts, and also respond to user actions like clicks and scrolling. Each task is managed by separate thread to keep the browser responsive. In the web servers as well, it's been used in web servers. Web servers. Web servers like Apache or Nginx handle multiple client requests concurrently. So each request is processed independently using threads or asynchronous I/O. This allows the server to serve multiple users without blocking at all. Example for chat application in any chat app. In a chat app, concurrency ensures first incoming messages are processed, the user interface updates in real time, outgoing messages are sent without delays. It's been used also concurrency in video games because rendering graphics, processing user inputs like character movement, simulating physics, playing background audio, etc. This ensures a smooth gameplay without lags. Okay, we can talk about talk about a code example, but I want to make everything simple here, so I will not go to code example because I don't want to overcomplicate the stuff. Okay, so let's try to understand what is the advantages. Oh no, I will just type it. What is the advantages of concurrency? And there are a lot of things, but we can only focus on three things right now. The first thing is improved responsiveness, because applications like web browsers or chat applications remain responsive even when performing heavy operations. The second thing, better resource utilization, because the CPU stays busy all the time handling tasks efficiently instead of waiting for slow operations like I/O. Third, scalability. Concurrency enables systems to handle multiple users or tasks without slowing down at all. But there are challenges. Let's put it here. There are challenges. I'm pretty bad at pronunciation. Yeah, there are challenges. The first thing, we have race conditions, because when two threads access share the resources simultaneously, it can lead to unpredictable behavior. The second thing, we have a deadlocks, like two threads waiting for each other to release resources can get stuck forever. Three, we have context switching overhead, like too much switching can slow down performance instead of improve it. These challenges can mediate with proper synchronization, locking mechanisms, and efficient thread management. And we will talk about each one of them in videos in the future. So, and that's concurrency in a nutshell. It's the magic behind everything from responsive apps to high performance servers. If you enjoyed this video or found it helpful, don't forget to like it, share it, and subscribe. Let me know in the comment section below if you would like a deeper dive into parallelism or a specific programming example. See you in the next video, guys.